Welcome to this presentation regarding lunar phases. It's a topic I hope to shed some light on for you. I am Jim Roucis, and I'm a member of the Albuquerque Astronomical Society. I joined the society in July of 2017, but I've been an astronomy enthusiast since my youth. Please bear in mind that I'm just a fan of the night sky. I'm not an expert in solar system dynamics, nor celestial mechanics, nor selenography. Nonetheless, I've researched the work of other talented and experienced folks to arrive at this quick treatment of the topic, understanding lunar phases. So I apologize if I've included any inaccurate or confusing information or inadvertently omitted key concepts, but I think overall this will give you a reasonable understanding of the subject. I raised a set of twins, and as they matured, they went through many phases. Most of them were very difficult to understand. But you're in luck today. Lunar phases are much easier to understand. They're even predictable. The background image you see here, taken on December 28, 2008, is a conjunction, which is a fancy astronomy term for a gathering of objects in the sky. This conjunction includes the Moon, Mercury, and Jupiter. A very young crescent moon hangs just above the horizon, with Mercury near the center, and near the top of the frame is bright Jupiter, and you might be able to just barely make out its moons on either side. Some media in this presentation is sourced from NASA and its affiliates, while the rest of the images are courtesy of my friends, whom I refer to as Lunaclicks because of their affinity for snapping pictures of the moon. So let's talk a bit about the focus of the presentation, Earth's moon. The moon is on our front doorstep, so to speak, relative to other places in the solar system, not to mention our solar system's place in the Milky Way galaxy. At an average distance of about 240,000 miles, the journey for Apollo astronauts was still several days in both directions. Here, we see a boot print from one of the Apollo 11 astronauts. Our fascination with the moon eventually drove us to visit in person, a feat considered extremely dangerous and difficult today, even after a half-century of technological advancements. The moon has figured prominently in our art, literature, and music. It's an icon of the human experience. Some may ignore the moon, but I think most of us have at least some urge to pause and look when we see it rising, setting, or just hanging in the sky. It's almost always there, but with varying locations and illumination from night to night and morning to morning. These changes must have puzzled our distant ancestors, and I bet they were asking the same question that we're going to ask right now. What is going on with the moon? Thanks to science, technology, and our insatiable urge to explore, we now know that the motion and changing illumination of the moon you experience on Earth arises from the fact that it is a large solar system body orbiting Earth. The moon orbits in an eastward direction while the Earth rotates eastward on its axis. You will see that clearly in an animation on another slide. It is important to understand that a full orbit of the moon around Earth takes approximately 29.5 days. The upper portion of this slide's background, showing a small Earth that you see here, and an even smaller moon that you see here, is not a collage. Instead of being separate images pasted together, this is an actual portrait made of the Earth-Moon system. It was captured by a spacecraft called OSIRIS-REx as it sped away from Earth toward its target, an asteroid known as Bennu. The MapCam instrument aboard the spacecraft recorded this portrait of our home on October 2nd, 2017, when the spacecraft was approximately 3 million miles from Earth. That's about 13 times the distance between the Earth and the Moon. The image in the lower portion of the frame is a collage, and it shows a progression of over approximately 2 weeks as the Moon brightens from a thin crescent all the way to full. And we know that this changing of illumination, this brightening that happens, is a direct result of the Moon's orbit around the Earth. During each orbit, the Moon passes through 4 special points that have been given descriptive names. Let's learn about these points in the lunar orbit. In this illustration, and on several slides that follow, you are looking at the Earth-Moon system from far above the Earth's North Pole, about right here. The Sun is off to the left, its light is streaming across the slide this way, and the distance between the Earth and Moon is shown at 1/5 the normal separation. So this depiction of the Earth-Moon system in this portion of the slide is an approximation simply to show the Moon's position in its orbit. In the upper right-hand corner of the slide is an image of how the Moon would appear from Earth at the given phase in question. The image on this slide is difficult to see, and you will soon understand why. A new moon occurs when the Moon is between the Earth and Sun in its orbit, and this can be thought of as the beginning of the orbit, or day 0. Imagine standing on the daytime side of Earth trying to see the Moon in the sky. As you look in this direction, you're essentially seeing an entirely shadowed portion of the Moon. At this point in the Moon's orbit, it is also very close to the Sun in the sky. And since none of the Moon's surface facing you is illuminated by sunlight, any scattered light reflecting off of the shadowed surface facing you is completely overwhelmed by the Sun's glare. This is why the depiction of the Moon's appearance from Earth for the new moon phase is obscured. Essentially, a new moon is invisible to us from Earth. In order to see any of the surface of the Moon reflecting sunlight, you must allow the Moon to progress in its orbit a day or two so that it moves away from the vicinity of the Sun in the sky. At such time, a very thin crescent moon can be seen after sunset. In this graphic, the Moon's shadow is cast in the direction of Earth. When the Moon's shadow falls on the Earth's surface, a solar eclipse occurs. Should this happen every new moon? That would be the case, but only if the plane of the Moon's orbit around the Earth was exactly aligned with the plane of the Earth's orbit around the Sun. But we know that solar eclipses happen much less frequently than at every new moon. Why? The Moon's orbit around the Earth is tilted about 5 degrees from the plane of the Earth's orbit around the Sun. This might not seem like much, but it's enough to cause the Moon's shadow to miss Earth's surface often, and only rarely do things line up to result in a solar eclipse. Now let's learn the next major point in the Moon's orbit around the Earth. The first quarter moon occurs between 7 and 8 days after new moon phase. In that time, the Moon has completed 1/4 of its orbit around Earth. Remember that it was here as the orbit began when the Moon was new, and now it's here. It's 1/4 of the way around Earth and on approximately 90 degrees from the Sun's location in the sky. Imagine standing in the shadowed area near the day-night terminator here. The Sun has just set for you, so looking up from here, you see the Moon high in the southern sky. From your vantage point on Earth, the western half of the Moon is bathed in sunlight, while the eastern half of the moon is in shadow. Many people call this a half moon, which is descriptive of its illumination but does not accurately identify its current phase. You now know to call it by its proper name, first quarter moon. Because you're standing on a rotating planet, spinning around this direction, the moon arches lower towards the western horizon as the evening hours go by. So what's the next stop in the moon's orbit? The beginning of the moon's orbit is referred to as new moon. The next stop is first quarter. So should you call the next stop in the orbit second quarter moon? Perhaps, but instead, this special point in the orbit is known as a full moon, because the entirety of the moon's surface, pointed towards Earth, is bathed in sunlight. The full moon is special for two reasons. First, it's fully illuminated, as we see here, and second, it rises in the east as the sun sets in the west, and then sets in the west as the sun rises in the east the next day. So the full moon is visible in the sky for the entire night. In this graphic, the Earth's shadow is cast in this direction, toward the right on the slide. When the moon enters the Earth's shadow, a lunar eclipse occurs. Should the moon be eclipsed every time it's full? Just like the scenario for a solar eclipse, that would be the case only if the plane of the moon's orbit was exactly aligned with the plane of the Earth's orbit around the sun. Again, a slight tilt of the moon's orbit around Earth makes lunar eclipses rare in a similar manner to the rarity of solar eclipses. So what's the next major stop in the moon's orbit around the Earth? Another quarter of the moon's orbit has passed at this point, so the phase is aptly called third quarter moon. This phase may also be referred to as last quarter. Again, the term half moon is applicable and often used. As we see here, half of the moon is bathed in sunlight and the other half of the moon is in shadow. But note that this does not distinguish between this point in the orbit and the first quarter moon. Both points in the orbit show half of the moon's surface illuminated as seen from Earth. Note, however, a difference. The eastern half at third quarter is now bathed in sunlight, and the western half is in shadow. At first quarter, it was the other way around. The western half was bathed in sunlight, and the eastern half was in shadow. Let's go back and have a look at that. This is the first quarter moon, western sunlight, eastern shadow. And now at third quarter, eastern sunlight, western shadow. So what comes after third quarter moon? Well, the moon's going to continue in its orbit and wind up back here. And the question is, does that mean that this would be a fourth quarter moon? Well, sort of, but actually the orbit cycle repeats. Beginning with what phase? Well, of course, we learned this phase is called new moon. So you now know about the four major points in the moon's orbit around Earth, and you've seen how the moon appears in our skies at each of these phases. But what does it look like at all points in between? Let's use a NASA simulation to show the moon's illumination gradually changing throughout its orbit around Earth. On the left side of the animation, you're looking down at an angle on the Earth-Moon system, with the sun far away in front of you. The Earth and Moon sizes in this portion of the animation are greatly exaggerated, and their separation is not to scale. They simply show the position of the Moon as it orbits around the Earth. On the right-hand side of the animation, you see the corresponding appearance of the Moon as viewed from Earth. The animation shows about 2 months of time. Let's start the animation and carefully watch the Moon's illumination change. Notice Earth whirling around on its axis while the Moon orbits. Remember that Earth rotates nearly 30 times for every orbit of the Moon, so at this speed of Moon motion, Earth looks like it's turning very quickly. What phase of the Moon do you see here? Notice the depiction of the Moon as seen from Earth is obscured. You remember what that means? You got it. This is new moon phase, and the Moon essentially can't be viewed from Earth. Let's move on. Here, the Moon is just a few days past new. Imagine standing just within the shadowed part of the Earth. Sunset would have recently occurred, and you would be staring just above the western horizon to see the Moon. At this point in its orbit, only a small portion of the surface of the Moon that is illuminated by sunlight is actually facing your direction. So, you see this beautiful crescent moon shown here. The Moon was recently new. Now a week or so has passed, and you see the western half illuminated and the eastern half in shadow. What phase is this? That's correct. You see a first quarter moon in the sky. About another week after first quarter, you see the entire Moon illuminated. And of course, we know what this is, what phase this is. We just learned it. All of the surface of the Moon that's pointed in your direction is bathed in sunlight. This is, of course, a full moon. About another week after the full moon, you see the eastern half is illuminated and the western half is in shadow. What phase do we have here? Of course, this is third quarter. As mentioned earlier, the Moon continues in its orbit, and the process begins again. The animation also shows an interesting situation. One side of the Moon always faces Earth, so the Moon rotates exactly once per orbit around Earth in accordance with a phenomenon known as tidal lock. In the diagram on the left, you see the Moon as it would appear in our sky with the 4 phases you just learned: new, first quarter, full, and third quarter. But what about the various illuminations in between? How can we describe these? To do so, you use the 4 words shown here. The first group of words describes whether the Moon is getting brighter or dimmer each night. The second group of words describes the amount of the Moon that is illuminated. By joining these terms, you can tell much about the Moon's phase with just 2 words. Historically, the descriptions of the Moon's phase has always been formed with a word from the first group joined with a word from the second group. The term waxing describes the portion of the moon's orbit during which more of the moon is illuminated from night to night. So after the moon is new, it gradually begins to be illuminated. And this is the waxing portion of the moon's orbit. It starts from new, where none of the surface pointing towards you is illuminated, and it gradually gets brighter and brighter each night until it's full. That is the waxing portion of the moon's orbit. Waning describes the portion of the moon's orbit during which less of the moon is illuminated from night to night. So, as the moon is full and all of the surface pointed towards you is illuminated in sunlight, as each night goes by, less and less of the moon is illuminated and more begins to enter shadow until the moon is new, where it is entirely shadowed. So this is the waning portion of the moon's orbit. These terms are easy to confuse, so I use this analogy to remember what waxing means. You apply wax to your car to make it brighter and shinier. So remember that during the waxing portion of the orbit, each night the moon's getting brighter and brighter. And that's what you would like to happen when you wax your car. You want it to be brighter and shinier. And then waning, of course, is the opposite. The term crescent applies to a moon that is less than half illuminated. So at first quarter, half of the moon is illuminated. At third quarter, again, half of the moon is illuminated. They're different halves, but nonetheless, half of the moon is illuminated in each of these cases. In between third quarter and first quarter, less than half of the moon is illuminated, as we can see in these images here. So this is the crescent portion of the moon's orbit, from third quarter to first quarter. A gibbous moon, on the other hand, is a moon that is more than half illuminated. So at first quarter and third quarter, the moon in both situations is half illuminated. In between, more of the moon than half is illuminated. So this portion of the moon's orbit is the gibbous portion. We had the crescent portion here and the gibbous portion here. A crescent moon is easy to remember if you compare it to the arc shape of a crescent roll. A gibbous moon, on the other hand, has lost that crescent shape or that arc shape. So what two words would you put together from the groups of words that we have to describe a moon with this sort of illumination? Remember that this is the waxing portion of the moon's orbit. Also remember that this is the crescent portion of the moon's orbit. So what two words would apply to this illumination of the moon? Correct. A waxing crescent. As the moon moves past first quarter, it gets brighter each night, with more than half of its surface illuminated. What phase would this be? Indeed, that's a waxing gibbous moon. Why? Remember we were in the waxing portion of the moon's orbit here, so that's where the term waxing comes from. We're also in a situation where more than half of the moon is illuminated. We're in the gibbous portion of the moon's orbit. So at this point, between first quarter and full, we see waxing gibbous moons in the sky. After the moon is full, we notice that less and less of the moon is illuminated each night. So how would we describe this phase of the moon? Well, we are in the waning portion of the moon's orbit, but we're also within the gibbous portion of the moon's orbit. So this, of course, would be a waning gibbous moon. This moon is past third quarter, getting dimmer each night, and it has taken on that unmistakable shape that we just talked about. What do we have? How do we describe that phase? That's right, this is a waning crescent moon. Now you have a complete dictionary of terms you can use to describe the major phases and the moon's appearance between them. You can impress your friends now when you explain that a beautiful waxing gibbous moon hangs in the eastern sky, as an example. You've seen how the illumination of the moon changes as it orbits Earth. But what does this look like from your backyard? Let's run a simulation to demonstrate this progression. This image and those that follow were derived from Starry Night Pro planetarium software. You see a fisheye view looking south an hour or so after sunset. West is on the right side of the slide, and that's the direction of the sunlight illuminating the moon. Each slide shows the same view 24 hours later. So this simulation shows the motion and changing illumination of the moon if you stepped out at exactly the same time each night, facing due south. The time chosen is long enough after sunset for the sky to be nice and dark. We start 2 days after the new moon. Why? Well, you already learned that it's impractical to view the new moon. So here you see a thin crescent moon about 2 days after new, low over the western horizon. Let's see what changes occur when you step out the following day. The moon now appears higher in the sky and slightly more illuminated than the evening before. So what happened? The movement you see is due to the moon progressing about 1/30th of its way around Earth in that 24-hour period. Let's see that again. Here's where we started on day 2 of the lunar orbit, and 24 hours later, on day 3 of the lunar orbit, the moon winds up here, slightly higher in the sky, slightly brighter than the night before. So what happens the next day? Again, the moon moves another 30th of its orbit, so it is higher and brighter in the sky. Note that you're still looking at a waxing crescent moon because it is brightening each night, but has not yet reached first quarter. And the next night, we see the moon higher and brighter, and again, higher and brighter, getting close to first quarter, but not quite there, until now. About 7 days after the lunar cycle began, we see this major phase, first quarter. It's actually not due south in this image, because remember, we're looking at the sky more than an hour past sunset. The next night, something special happens. You saw a waxing crescent moon each night until it reached first quarter. It's now 1 day past first quarter. So what phase of the moon do you see now? That's correct. This is a waxing gibbous phase. Let's see what happens the next night. More of the moon is illuminated, but we're still waxing gibbous, headed towards the next major stop. So here we are, about 2 weeks after the new moon. What phase are we looking at here? This one's easy. That's right, this is a full moon. So all of the surface of the moon that is pointed towards you is bathed in sunlight. This image is actually slightly prior to full moon, which officially occurs in the morning following this day. So let's move one more day into the future, and now we see the just past full moon hanging low over the eastern horizon. Remember that it was low over the western horizon as we began this experiment. You've now watched almost half of the moon's orbit around Earth. So now you know why the moon changes illumination and position in the sky from night to night, and you know the jargon to describe its various phases. It's time to impress your friends the next time you glimpse the moon with them. I have one more treat to share with you on the topic of lunar phases, an animation of the moon's appearance for the entire year. This animation is published every year by NASA affiliates, and it is packed with information. If you think it's as cool as I do, you should be able to find it by searching the internet for moon phase and libration. You're looking for a page that matches in the nasa.gov domain. On that page, you will find an interactive lunar phase utility and movie clips of the animation like the one used on this slide. A great deal of information has been packed into this animation. Over here, the current date and time appear in the lower right corner, along with the phase, diameter in the sky, distance from Earth, and more. In the upper left corner, you see a moon position indicator similar to those on other slides that shows the moon's position in its orbit around Earth, but with the distance between the moon and the Earth not drawn to scale. As in the previous animations, the Earth whirls around once per day while the moon orbit progresses. In the lower left corner, you see a gizmo that indicates the current lunar libration. Libration is a fancy term to describe an illusion of the moon's motion from our vantage point on Earth. The moon appears to bob and rock to and fro. It's a motion that's difficult to detect during the course of an evening, but obvious in an animation such as this. Two primary factors cause this effect. The moon's orbit is not completely circular. It's somewhat elliptical or oval shaped like an egg. And as you learned earlier, its orbit is tilted slightly from the orbit of Earth around the sun. These two factors combine to make the moon appear to bob and rock as we observe it from Earth, but it is not actually making these motions. Tucked behind the image of the moon, near the center of the frame, you see a line with a small blue Earth image on the left and a tiny dot of the moon embedded in a yellow circle on the right. The line between these images is a scale indicating the moon's distance from the Earth at any given time. Note that the distance between the images of the Earth and the moon is actually to scale in this depiction, rather than an approximation as seen on other slides. The scale is in Earth diameters rather than in miles or kilometers. An Earth diameter, this distance here, is slightly more than 7,900 miles. Since the moon's orbit is not perfectly circular, its distance from Earth varies in the range that we see here, between 28 and 32 Earth diameters. As the moon moves closer to Earth, it appears larger in the sky. Obviously, as it moves away from Earth, it appears smaller. You will see that effect as the animation progresses. As if all this information was somehow insufficient, key and interesting features on the moon are labeled at any given moment, so you can stop the animation at a date and time of interest, and you can see all the cool stuff on the moon identified with its associated names. You can observe some or all of these points of interest if you have good binoculars or a capable telescope. How cool is that? So let's start the animation. Notice the bobbing and rocking the moon appears to do. That's the lunar libration phenomenon. Also notice the diameter of the moon grows and shrinks in direct correlation to its distance from Earth. So if we watch this indicator move back and forth, here we see a smaller moon in the sky. Later on, as the indicator moves to this position, we will see a larger moon in the sky. Notice, though, that the difference is not dramatic. When the moon is far away, it's slightly smaller in the sky. When the moon is closer by the Earth, it's slightly larger. Let's stop the animation for a moment. Oops. Let's stop the animation for a moment and look at the labeled points of interest. Notice you can see the Apollo landing sites. Those are labeled all the time. So you have a reference that shows you where we have actually visited the moon, set foot, walked around, run experiments, and then returned home. But also notice that there's some very interesting craters and so forth labeled along this line that separates the illuminated portion of the moon from the shadowed portion of the moon. That separation line is called the terminator, and this is often where you see the most contrast between things that are bathed in sunlight and things that are in shadow. And that makes the details much more interesting than a feature that's fully illuminated. The contrast is very low on a fully illuminated feature. All right, let's continue. What an amazing animation. I really applaud the folks at NASA and their affiliates for providing this detailed tool for lunar exploration from Earth. I hope you enjoyed it too, and maybe you can actually make use of it in your own observations of the moon. Thanks for taking time to learn about lunar phases. I hope you found the presentation instructional and enjoyable. If you have more curiosity about the moon or astronomy in general, consider joining the Albuquerque Astronomical Society. You can learn about us at the website TAAS.org. Thank you.